So far we've learned about SN1, SN2, and E2, and these are the primary reactions of the alkyl halides with nucleophiles and bases. There's one other reaction that's not so common, but it is still important to learn the mechanism of, and that is something called E1. As you probably already have guessed, an E1 reaction is elimination, and it's unimolecular because there's only one thing in the transition state. It's very similar to the SN1 reaction, and if a compound will undergo an SN1 reaction, it can be made to undergo an E1 reaction also. The rate-limiting step has just one molecule in it, and it's a halide, just like the SN1 reaction, and so the leaving group leaves. This is not a common reaction, and in order to have E1 occur, we usually have to heat up the compound a bit in order to make it actually go. The reaction profile for this is very much like the SN1 reaction. The leaving group leaves and we form the carbocation, and then the base removes a proton and the alkene forms. The reason that this is not very common is because the base tends to want to remove the hydrogen first. When does E1 occur? When the base is very weak. So usually if we want elimination to occur, we're going to put a good strong base in there. When does E1 occur? When you don't have a strong base and you're heating up the compound, and then it's forcing the compound into doing elimination, and anything that's in there that can act as a base, whether it's basic or not, will have to pick up the proton. The rate equation for this is just like SN1, and its rate is equal to the rate constant times the alkyl halide. It does occur under the same conditions as SN1 because a carbocation has to form. So tertiary is best, protic solvent is best. It's usually under acid conditions and or heat. So it's pretty harsh conditions, and you can have some bad things happen to the poor compound. It's not terribly common. It's really common to see heat. E1 is not stereospecific because there is a carbocation forming, and once a carbocation forms, you can have rotation occur all over the molecule before the weak base removes the proton. Cyclohexyl halides do not require an axial configuration, and this anti-periplanar arrangement is not needed. It's just helter-skelter. So, how do we compare E2 to E1? It's really easy. If there's a strong base and, of course, a non-protic solvent, what do you get? E2. Even if you just have a strong base and a protic solvent, you're going to have E2. E1, what's going to happen? A protic solvent and a weak base, and almost always heat. And in both of these, the more substituted alkene is formed. With E2, we also have the additional requirements of anti-periplanar arrangement for elimination. Well, how do we determine whether SN1 goes or E1 goes? Well, the lower temperatures favor SN1, higher temperatures favor E1. So it's really temperature that determines whether SN1 or E1 occurs. So if you're looking at a reaction and you see that it's tertiary and there's protic solvent, look to see if there's heat. If there's no heat or it's a low temperature, SN1 is going to occur. But if you're heating this thing up or it gives you a high temperature, then you're going to say, okay, E1 is going to occur here. Here's an example. Here is a tertiary halide. There's a protic solvent. Of course, it has to be SN1 and not SN2. But there's no base here, so it can't be E2. So we're trying to say, is it going to be SN1 or E1? Well, we looked and we see there's heat, so we know the alkene's going to form. However, if there was no heat here, what would we say forms? Well, it's going to be the substitution product. Alternatively, it could say 100 degrees Celsius. Well, then your major product would be the alkene. What if it said 25 degrees Celsius? Well, that's going to be your alcohol is going to predominate. So now it's time for you to try it. Take a look at these two reactions and see what mechanism should apply, and then determine what product will form. Okay, I look and I see that we have a tertiary halide. The solvent is protic and we have heat. There's no base. It's an acidic condition. Well, that's going to be conditions for E1 to occur. So what do we get? We get an alkene forming. Notice we get the more substituted alkene forming between the more highly substituted carbons. In this compound, we again have a tertiary halide, but now we've got base. What's going to happen? Rotation will occur, and we're going to get anti-periplanar set up in the mechanism, and the arrangement of the carbons is going to be like this because rotation has to occur before elimination occurs. That's an E2 mechanism. So in determining the outcome of a reaction, what you need to do first is look at the carbon compound. Classify it as primary, secondary, or tertiary. If it's primary, it's going to be either SN2 or E2. It'll be SN2 unless you have T-Bach in there. If you've got T-butoxide, well then it's going to do E2. If you have a secondary carbon, now you're going to look and you're going to say, well, it can be either SN2, SN1, or E2, or even E1 if you want. So they really can do all of them. If you have a polar aprotic solvent, you're going to do SN2 if there's no strong base present. If there's a strong base present, then it has to be E2. If it's a polar protic solvent, look and see look and see if you have a base in there. If you have a base, it's going to give you E2. If you don't, you're going to have SN1. If you don't have a base and you have heat, well then you're probably going to have E1 occurring. If it's tertiary, you're going to have SN1 occur if it's a weak base. If it's a strong base, well then you're going to have E2. If it's a weak base and there's heat present, well then E1 will occur.